All right, so the next couple things I want to do is turtle dot pen up because I'm going to move and I don't want to draw. Let's go to, let me look at my notes, 60, 60. And let's say I wanted to do another square. Well, I'm going to have to kind of repeat myself. Uh-oh, I'm repeating myself. I'm repeating myself. So I don't actually want to repeat myself. I don't actually want to repeat myself. Okay, that joke's getting old. But if I did that for loop, I forgot to do pin down. So see, this is very annoying. That I'm having to go back and repeat myself every time I want to draw a square. So this is, sorry, I can't talk and do this. Let me just finish up this thing that I'm trying to do there. Boom. Okay. So this is my window to my house. So what I was trying to say is this is another powerful tool in programming, which is called a function. We've already talked about functions, actually. All of these are functions, left, forward, pin down. But now we get to write our own function. And to do that in Python, we use this def keyword, short for define. And then I want to write the name of the function, which is square in my case. Square has blank parentheses here because I don't want to put anything in it just yet. But then, just like with the for loop, I need a colon, and then I need to tab over anything that goes inside the definition of the for loop. Well, let me do the rest of what we had in here. I want to repeat this 4 times, and I want to do turtle forward. I want to do that just 10, and then I want to do left 90 again. Okay, so now notice that it didn't actually draw a square. If I wanted to do that, I would have to call the square function that I just created, square. Okay, notice that in dir, I've got this I, which is sort of a residual of this counter that I had. I've got turtle, which is the module that I imported, and I've got square, which I just defined. Okay, so square does that thing. Let me do turtle.pin up, and then turtle.go to 40, 60, so I can put my other window in there. And then don't forget turtle.pin down. And now let me do my square again. So what I did was, that's ugly. But what I did was I took all that code and I bundled it up into a function. And now I can use that function however many times I want to. So that is a fundamental concept of programming using functions called abstraction. So I'm taking all the details of how square is done, and I'm bundling them up and I'm packaging them away. And I don't care about how it's done. I don't care if it goes forward and then left 4 times, or I don't care if it turns and then goes forward and right. I don't care. I just want to know that it's drawing me a square. Okay, so I'm abstracting away the details. So I made a function called square, but as you can see, that only makes a little square because in the definition of my function, I wanted it to go forward only 10 pixels. If I wanted a big square, I could not currently say I want a square that's size 100 because square takes 0 positional arguments. So what we need to do is redefine square and put in a positional argument. I could just call it x, but I'd rather use a really nice name called size. So let's redefine square with a parameter of size or an argument named size. For I in range 4, because it's going to be a square, I don't need that to change. And then I'm going to do turtle.forward. And now instead of going 10 or 100, I'm going to just go size. And that's a little bit weird, but let me kind of demonstrate what's going on using this notepad over here. If you've already taken algebra, you understand algebraic concepts, this is called function notation in algebra. Let's just do f equals x squared, or let's do 4x plus 3. Okay, that's kind of easy. So that's a function, just like what we've got here in computer science. This x is the input, okay, and then f is the function that produces the output, which kind of turns into y there. So it's kind of the same thing here. Square takes in the input of size and then does something according to size, and then the output is different. Okay, so if in this one I put in f of 2, that's going to be 4 times 2, which is 8, plus 3 is 11. Okay, so that's going to produce one particular output. Same thing here. If I do square of 100, then size is going to be 100. So it's going to, wherever this is, it's going to substitute in that variable size with whatever I use when I call the function. Okay, that'll make a little bit more sense when I actually use it. So there's turtle.forward size. And notice that I've got 2 levels of indentation here because I've got 2 blocks. I've got a block, a for loop inside a block, the function here. Okay, so turtle left, in this case, I want to do 90 because I want it to go 90 every time. So those couple of numbers are constant according to my square. All squares have four sides, and all squares have 90-degree turns, but not all squares have a constant or a given size. What I want to do now is when I call square with a size, whatever that may be, it's going to actually draw a square of that size. Okay, I can do 400 if I want. Of course, it'll go way off the screen. Hopefully my turtle will come back. There it is.